Brian Taylor here, owner of Taylor Aircraft. Today I want to talk to you about Paramotor S-bars. I want to show why we chose to use the materials that we did and just a couple small considerations, especially since we're going to be selling these aftermarket for even people that want to make their own paramotor but need to buy a set of arms. We want to show why ours might be a strong consideration for your project and why they're so good on our existing paramotor. So for one, you'll see that many paramotors on the market, the manufacturers in general, they don't even have bushings or bearings, and they'll use a small substandard bolt as the main connection point. And as your risers and different forces can bend and pry, it can actually snap this bolt. You'll see a lot of manufacturers actually have a backup safety strap. It doesn't need to be like that. A connection point and an S-bar doesn't need to be the weakest part of the paramotor. Also, if you don't have proper thrust washers and things like that to take away friction, as your paramotor, even if this bolt is Loctited, when your paramotor bars flex outward and put a pressure under that washer and lift up and down, it'll start loosening that bolt. I've had a few friends on different manufacturers that said, man, even Loctited after 3-4 flights, my bolts are getting loosened up. And that's because they haven't taken away the friction by using bushings, bearings, and proper hardware. In addition to that, on ours, we use, instead of 60-61, we use 70-75 T6. 60-61 is more than sufficient. It's about 42,000 PSI as far as the strength on it, and 70-75 is 78,000. It's almost double the strength. 70-75 is basically as strong as steel. So our S-bars are extremely strong, some of the strongest on the market, and can take a lot of load. But let me set this one down, and I'll just show you what's a little bit different on ours. We haven't drilled ours up yet, but you'll see we have actual needle bearings in here. We've got a 3/8 diameter CAD plated aircraft bolt. Would go on basically a giant aircraft is what's supporting your life with ours. And then it also goes through a needle bearing, and then there's a nylon thrust washer on either side to take the load. So there's no friction. You're not going to pry and create any sort of a kind of like a friction wrench to loosen the bolt. Spins free and true like it should. Standard connection hardware. I always wondered in the paramotor industry why no bushings and bearings are ever utilized. It's kind of scary actually. But in addition to that, that 70-75 is just extremely durable, and because we want to be able to mount our trikes to our paramotor and lift all the load from it, we want this to be just something you don't ever have to worry about as far as safety concern. This is one that's finished up. This is just raw. But anyway, there's not a whole lot you can do different with the S-bars, to be honest with you. We don't need to really make them adjustable. I get it for different harnesses, different things, but some of these paramotor S-bars that have all these adjustments, one, there's more hardware that can get snagged on your lines. But the reality is, the way the seat is designed, see, the strap is perfectly straight up and down, but there's no adjustment on it. So when you mount your seat to your paramotor, you can't just stretch this out without this being at a weird angle. Now you don't have even tension on the straps. So you don't need a whole lot of adjustments on these bars. They work great, just a solid mount. Now, a few manufacturers, you know, I wouldn't say gimmicky, but to look a little bit different, to do different things, you'll see a couple of them have chosen to make like a wraparound S-bar. And there's one problem with that. So when I design something, I look at every implication, not just what looks good, what's strong, but also functionality in all aspects. And that's where a lot of manufacturers, I think they look at more what looks good, just another gimmick, what makes them stand out. But I'm all about functionality. If something works a certain shape, strength, design, safety, then it stays. So I don't like extra snag points. I have seen on a couple different manufacturers, or one of them, where they had a wraparound where a student had something, a strap. See, we got buckle straps. If you have something that can get hung up in there and it won't allow your arm to articulate like it should, it's another snag point. So I don't want anything being able to really catch on this bar, so I don't want to create a loop. But there's one key feature that's really important with that too, and that's, get in. Okay, Now that's as far as comfort overall. So with flying, I have very limited space. This is my entire cockpit. My arms are at a certified width for this actual certified width for the paraglider wing. So, and the way I've done the connection point, we've got plenty of clearance where it's not hitting underneath your armpit. So these are drop down, gives you extra weight shift. But anyway, back to the bars. So if I had a wrap around here, I would now take away space. So look, while I'm flying, I've only got so much room. If I have a chest mounted reserve, which a lot of us do, I can't reach my arms to get to anything here because I've got my chest mounted reserve, which is basically sitting in my lap. The only room I have is right in here. So sometimes when I fly in a long cross country and it's nice out, I can stow my brakes, and if I need to manipulate my phone or device, yeah, I could sit here like this, but what's really nice, these straps are extremely comfortable. So in flight, I can relax and just set my arms on the straps. Well, if I've got a bar coming here, I've now blocked a lot of this room. It's the only spot that if I need to reach, adjust, or do anything, that I can get to. So if I have a wider bar or a wraparound bar, I've completely taken away every access point I have. I can only really reach around. I'm sure you could still wiggle under here a little bit. It's fine. But look at all this room I have. That is huge. I use this space all the time. So I'm flying, I can reach through, adjust something, whatever it is, adjust my helmet. I can get my arms around here. So when I design something, I look at every implication, not just strength and safety, but functionality as well. I don't want one thing to take away from something else. So why would I want to add a potential snag point and take away an access point to be able to manipulate any devices or even just relax and chill out in flight? I love this. These straps actually make a really neat, almost like a little table. Yeah, you shouldn't fly without holding the brakes, but we know on a nice day you can just stow them, do a little weight shift, but this is the only access I have. So that's why it was important for me not to create a hoop there, but to make sure I was using the right material, the right size hardware to make an extremely strong S-bar that can hold the weight and the torque with this trike without having to have additional struts or supports, because if I'd use like a 60-61, it'd be a little bit weaker and I might want to reinforce that. But if I use a material that's almost twice as strong, now I can keep it thin, light, but you can also see I've left plenty of material. Some other bars we found a lot thinner in this area, the width of this. You don't have any room to drill it out, put a bushing or bearing without getting too close to the edge and weakening the material. So I have a generous amount of material all the way around here, generous amount of material all the way around here. You are not ever going to have this fail. Another implication, some of these designs have anodized bars. Anodizing creates a brittle shell, which is nice for certain things, but it can lead to micro cracking, and a crack can transfer all the way through even a very thick part. I'll do a video on this later, but basically on certified aircraft, in structural areas that could take bends and flexes and vibrations, you almost never want to use an anodized part because paint, powder coating, anything like that, that is a separate layer on the metal. When you anodize, you're creating a brittle, couple thousandths of an inch thick. You're changing the material composition of the metal, and you're making it very brittle. So once a micro crack starts by a certain amount of cycles and pulses, no matter how thick the part is, it can travel through and crack. Now, granted, as thick as most of these paramotors are, there haven't been failures. I'm not saying it's extremely dangerous, but it's not really an approved practice to anodize certain structural components on aircraft, so we stay away from that. I don't ever want to be responsible for a fatality because I just wanted something to look pretty. So for us, everything has to be safe, strong, and functional, and not take away another function or impede on that. So just something to consider. So as we start selling these arms for, third party, for people that want to make their own paramotors, don't get caught up on just aesthetics. And even if something's strong, It could look good, but also is it taking away something? That's the last thing I would take away in flight is access to, and that's also a safety implication too. Anything happens, I have more room to get my hands, grab a knife if I had to cut away a cord or anything. I don't want to take away any extra room if I can help it. So we really have thought when we see different designs come out, hey, that looks pretty cool here, but look what it did. So take a lot of time to just research every aspect and come out with just a great paramotor, great components, all working in unison together, nice, easy netting systems, the arms, crumple zone, a trike that'll attach. We got the electric version coming soon. So basically it's a one paramotor that can do anything you ever wanted, but at the same time, the arms, this is your lifeblood. They need to be mounted securely so you don't have to have any unease in flight. What if? We don't want any what ifs. I don't want anything getting caught up, hung up, or breaking or bending in flight. So there you have it. Just a couple little things to consider. Anyway, take care. Brian Taylor.